I'm Dan Rein. I'm the chemist here at Jonas and Company. This is the second one. I'm planning to do 4 total. The topic of this one is about the chemistry of chlorine. As you know already, probably chlorine functions both as a sanitizer and an oxidizer. And it's one of the most important components of water treatment, wastewater treatment as well, and recreational water, which is pools, spas, all that good stuff. So it's one of the most important things in water treatment, and this is why. Here's why. So uh, sometimes pools look like this. So how do you get a pool that's cloudy or green to clear up? Well, a big part of that is chlorine. So it's like magic. You know, it can turn green pool into nice, clean and clear water. Clear it up all nice, but it's not magic. It comes from the chemical properties of chlorine. So chlorine's been used in water disinfection for over 100 years. So there's some history behind it. It's relatively safe, as has been proven by the history of using it for that length of time. And it's convenient because it comes in different forms. You can get it in solid form, liquid form. You can get a salt system generator, which is basically like having your own miniature chlorine generator that takes sodium chloride ions and uses electric current to turn them into a usable chlorine. So no matter what type of chlorine you put into the water, it turns into hypochlorous acid when it's mixed and dissolved into the water. And another way, chlorine is very useful is that chlorine and bromine as well, which contains chlorine ions. Bromine does, but only chlorine acts as both an oxidizer and a sanitizer. So chlorine is a stronger oxidizer than bromine, but it does have some oxidation. Any other swimming pool sanitizers like copper ionizers, like any other kind of sanitizer does not oxidize. You need a separate system or a separate chemical to do oxidation. And so you either have to use the chlorine to oxidize or a non-chlorine shock or some other system that oxidizes particles. So oxidation and sanitation, I'll talk about more about them later. Both are important for water disinfection, water sanitation, and the other important thing besides chlorine I just want to mention is good circulation, because if you don't have good circulation, the chlorine won't mix. It won't get in all the corners. It won't mix in with the total gallons of water. So I like this diagram. Shows how your jets should be positioned. Like as an example, you just want the water to flow all in the same direction around the pool, and so the returns are pushing water the same way that the skimmers are pulling it. So it goes in a big circle. And also up and down, you want water to circulate from the top to the bottom and bottom to the top, if you can. Depends on how your pool's designed, where the skimmers are and everything. But that's the best. The best way is to position them or adjust them to something like this diagram to get good mixing and when you shock the pool and everything. So shocking the pool has to do with oxidation of chlorine. So also known as superchlorination, shocking, or oxidation are all the same thing. When you shock the pool, when you superchlorinate the pool, it oxidizes particles and breaks down inorganic and organic compounds that might be clouding up your water, contaminating your water. It breaks those down and helps clear up the water. So I recommend, so when you superchlorinate, you want to add a high level of chlorine. Basically, if you add 2 pounds per 10,000 gallons, you'll end up with 16 ppms. If you can double that up to 4 pounds, you'll end up with 32 ppms. So just to give you an idea of so the normal chlorine level in your pool should be between 1 and 4, at least 1. So when you superchlorinate, you're going at least 10 times higher level than the normal level that's in your pool. Yeah. So, okay. Also at the bottom, you can see different types of chlorines, and calcium hypochlorite is the most concentrated. About 1.3 pounds will increase 10,000 gallons, 10 ppms. And sodium hypochlorite is liquid. Lithium, I don't know anybody that uses lithium right now. And dichlor is not as concentrated. 1.5 pounds will increase 10 ppms. So let me talk a little bit about how does chlorine work. So no matter what type of chlorine you add to your pool liquid, solid chlorine generator, it turns into hypochlorous acid, which is HOCl and OCl, called hypochlorous acid. So no matter what type you add, it gets used up. It doesn't just stay in the water. It reacts with things in the water, so it gets used up or decomposes by either interacting with things, or it gets decomposed and used up by the sun. So for sanitation, what that means is that the normal level of chlorine, 1 to 4, that's enough to kill bacteria, algae, microorganisms to an extent that's considered safe for humans to swim in the water. Okay, so that's the first process that chlorine's involved in, is sanitizing your pool so it's safe to swim. Nothing should be living in the pool except for people. So during that process of sanitation, there's a side reaction where the chlorine gets combined with nitrogen, with inorganic nitrogen compounds, and it forms chloramines, or disinfection byproducts, which are, you measure them as, it's measured as combined chlorine, and they're amines. They're called chloramines because they're amines with a chlorine that attaches to them. So they form these chloramine compounds. So you guys probably already know they have like a strong, like fishy smell, or like a strong chlorine fishy smell. Amines are the same compounds that are in seafood, that are in fish. So chloramines have like a really strong kind of fishy chlorine smell, which is different from just the chlorine smell. Regular chlorine sanitized water doesn't smell as strong as the chloramine. So the chloramines actually irritate your skin. They give off gas, so it's like an indoor situation. If you have chloramines build up, it creates poorer air quality from the off-gassing from the chloramines in the water, off-gas into the air. Outside, that's not such a problem. Let's see. So during sanitation, these chloramines, which you don't want in your water, get formed. So the chlorine in the chloramines also has some disinfection properties. It also kills bacteria, but it's not nearly as strong as hypochlorous acid. So free chlorine, also called hypochlorous acid, is measured as free chlorine. So we want free chlorine. We don't want chloramines in the water. And the way that we achieve that is when they start to build up. First of all, you can measure the free chlorine total chlorine, subtract the free chlorine, and then you'll find out what the combined chlorine is. So if you have any combined chlorine level above like 0.4 or even above 0.4, you should shock the pool to prevent them from building up. as you'll see later, the more they build up, the harder it is to get rid of, the more chlorine you have to use to break them up. So, but the way you get rid of them is by oxidation, which is shocking or superchlorination. So what this process of oxidation is just using introducing a high ppm level of chlorine into the water, and it breaks down contaminants. It breaks up the chloramines and returns the chlorine ions to the water as free chlorine, and the nitrogen part of the compound gets off gassed, broken up and off gassed into the air. So the way chlorine actually works is the oxygen part of the HOCl, the oxygen, pulls electrons from different organic or inorganic matter. So by pulling these electrons off, it breaks the compounds apart, breaks them down, and then whatever's left either gets off gassed, broken down into ions, or if it's precipitated, then particles they'll get picked up by the filtration system and backwashed out. So what cyanuric acid does is most people know this already, but it prevents the sun from acting on the chlorine and breaking it down and using it up. The sun breaks down chlorine pretty quickly. They used to have to add chlorine every day to a pool to keep it sanitized before they recognized that this cyanuric acid could be added to keep the chlorine in the water longer than that. So currently, the recommended level for cyanuric acid is 30 to 50 ppms. Any greater than 50 ppms doesn't show any additional benefits, and above 100 ppm shows clear negative benefits, and you should reduce that to increase your chlorine's effectiveness. So one thing I hear people say a lot is about how pH affects how well the chlorine works, which is true when there's no cyanuric acid present. But you can Google this study and find out and read it. But basically, what it shows is that when CYA is 12.5 or above, the pH does not have any significant effect on the free chlorine content in the water. Yeah, so if no cyanuric acid is present, the lower the pH, the more percentage of free chlorine, HOCl, and less OCl you have in the water. But CYA already lowers the effectiveness of the chlorine, and so that's the primary. The CYA is the primary determinant of how much hypochlorous acid concentration is in the water. The pH has little to no effect when CYA is present above that level. Okay, so just to talk about for a second, to mention salt systems, which I guess I already mentioned that, but I just wanted to make a slide to talk about it. Basically uses electricity to split the NaCl. NaCl is salt, so electricity will split the Na, sodium, and the chlorine ions, and hydrolyzes with water. The chlorine hydrolyzes and forms hypochlorous acid with the water. Yep. So same way that other chlorine forms dissolve into the water and form hypochlorous acid. So just like anything, there's a trade-off. There's some advantages, some disadvantages, including cost. the salt systems are not stabilized. So you need to add stabilizer, which is cyanuric acid. Salt can increase the corrosive index of the water, and also if it splashes out and dries, you're more likely to have salt build up on places that get water evaporated on a lot. And it also tends to raise the pH. So those are all considerations with a salt system. Yeah, especially with the shortage this year on tabs and other forms of chlorine. I'd say that would be one advantage to having a salt system for this year, though, for sure. Okay, so this slide I've shown before. You've probably seen it if you watch my other PowerPoints, but I just like it. I like how it shows how effective chlorine is. That even at 0.1 milligram per liter, which is the same as saying 0.1 ppms. Remember, pools are at least 1 ppms. They should be at least 1 ppms free chlorine. But even at less than 0.1, 10 times less free chlorine, it'll kill a lot of the bacteria that cause disease, E. coli and dysentery bacteria. So it kills them in less than a minute at 0.1 ppms. And so even at 1 ppms, which is a minimal amount that you would keep your swimming pool at, it'll kill other harder to kill bacteria within an hour or two. And that's this chart is at, I guess it's at 25 C, which is room temperature, and pH 7, which is very close to what we have our pools at, around 7 neutral pH. Don't worry about the 3 log reduction, but you can see the time it takes and the amount of free chlorine that's in the water to kill different bacteria. So this slide just gives you a comparison of some different types of chlorine: the liquid sodium hypochlorite, dichlor, trichlor, calcium hypochlorite. What the form is. So, and the available chlorine, which is how all chlorine products are measured, not by the weight percent, but they're actually measured by available chlorine, which is a measure of oxidation power. So the liquid is the least concentrated, as you know, 10 to 12%, and dichlor is between 56 and 60%. Trichlor tabs are the most concentrated at 90%. And the calcium hypochlorates are all around 70% available chlorine. So free chlorine residual should be maintained between 1 and 4 in pools, and 2 and 5, a little bit higher in spas. That's according to the, I believe it's the Model Aquatic Health Code, it's called. Okay, superchlorination, or shocking, should be performed when combined chlorine is greater than 0.2 ppms in pools and 0.5 ppms in spas. So it'll get much higher than that if you have a lot of people swimming in the pool. It's very easily could get up to like 1 or 2 combined chlorine. But yes, even at low levels, when it starts to build up, you can prevent it from building up by shocking. Oh, I'm sorry. I don't think that was the Model Aquatic Health Code. It's the APSP. APSP. So this diagram chart shows what happens when you shock the pool. So you can see, as you look on the left side, as the total chlorine residual increases. Okay, so the total chlorine is increasing. You start to get a strong chloramine odor. Chloramines are increasing. And so So the more that increases, the higher you're going to need to use a higher level of shock also to break them up. So what happens when you shock the pool is this is the break point. So it's called break point chlorination. When you use 10 times the tested combined chlorine, we're up to 30 ppms total ppms chlorine introduced into the water. It will break the chloramines. But if you add less than that, it will keep combining with those compounds. So it's like a certain point that needs to be reached. You need to, so it's all, say it's better to add, a pound more of chlorine than a pound less of chlorine, because the extra pound will eventually get used up in the water. But if you don't use enough, you're going to end up having to use even more than you started with, and shock it a second time. So once you get to once you overcome the combined chlorine level with new free chlorine introduced into the pool, it breaks those up, and the total chlorine level just goes down. The total goes down as the combined level goes down, and then you should that free chlorine should start to free up, and you should see free chlorine level over time. Over time, the free chlorine residual should start to increase as the total goes down, and that combined chlorine is broken up. So that shocks the water, freeing the free chlorine. Okay, and that free chlorine is much more effective, like hundreds of times more effective at more powerful than combined chlorine is at killing microorganisms. So I want to also mention with the chlorine shortage this year, and just in general, as a good practice, is if you use any algicides or borates, if you have phosphates, regularly using Phosex or a clarifier, any of these things used weekly will decrease your chlorine usage, because it'll take on at least some of the workload of the chlorine that's it'll interact with some of the things that interact with the chlorine and use it up. And so there'll be like a synergistic effect where you'll get better sanitation from combining supplements with your regular chlorine maintenance routine. You'll get better killing power, and you also end up using less of the chlorine chemicals. So yeah, these are just supplements, though. You couldn't use any of these alone to sanitize the pool, but they are registered. The Algicil, any of the algicides, the borax and the algicides are registered EPA products, so that means they've been proven to be effective at killing microorganisms. And actually, clarifiers are a similar molecule to the polymer algicides. So I would imagine they have some type of algicidal effect as well, in addition to just clearing particles from the water. The polymer algicides, they work by suffocation. They form a micelle, which is like a bubble around bacteria or algae cells, and it forms a bubble around it that doesn't allow metabolism to take place. And so it essentially suffocates the metabolism of the microorganisms. Some of the metal-based algicides, copper or silver, they're also good. They work a little bit differently. They use ionic charges similar to chlorine. They pull electrons and break down the cell walls of bacteria and small organisms. And let's see, borates. I don't think they're sure exactly how they do work, but I've heard a lot of good things about them, especially in pools that are hard to hard to keep a chlorine residual, that keep getting that keep having problems, or especially in situations like that. The borates, if you dose them at the beginning of the season, they won't leave the water. They don't get broken down when they interact with things. So besides dilution from rain or draining the pool, whatever you dose the pool at the beginning of the season of borates should last all season. And maybe I would test it once a year, or twice a year, to make sure to just check the levels. So okay, so any of these, hopefully you have some ideas now. Different ways to sanitize the pool and kill things that you want dead. So there's different ways to do that, but no matter what, the best thing is to test the water first. Then you know what you're dealing with, and you can figure out what's the best way to proceed. You can't really worry about balancing. Obviously, if the water is cloudy, in fact, the cloudy water could interfere with some of the test methods that we use. So first of all, if you want to test your water, you should just make sure it's clear first. Add chlorine, shock it until it's clear, and then after that, you can balance the hardness, pH, alkalinity, things like that. Make sure there's cyanuric acid in the water, all those things. But it's good to even with a test strip, if no matter if you're using a spin lab or if you're using test strips, it's just good to test the water before making any decisions. Then you have an idea of what's going on in the water, and test your tap water too, because you're going to be filling the pool throughout the year with the tap water. So you might want to know if that tap water usually has a higher pH in the pool, and every time you add it, it's going to raise the pH a little bit. Or if it has a lower pH, every time you add it, it's going to lower the pH potentially. So it's good to test, especially starting out. Test your water. Once you get a feel for it, you should get a feeling for how adding different chemicals affects the pH and other water balance factors. And you won't have to do it as often, but especially starting out, test your water every time you make a chemical addition or any type of change that'll change the chemistry, to get an idea of what that change did. If it raised the pH, if it raised the alkalinity, how much, if it affected the chlorine. And thanks for attending